Hey class, today what we're going to look at is exponential functions. So before we looked at kind of this pattern, we've seen this pattern before. We're multiplying by 5 each time to get to the next number. Now what we want to do is relate that to an equation. This equation is going to help us kind of jump to whatever term we need to, whether it's like the 40th or the 50th, 100th term, so that we don't have to just keep enter and enter and enter and do a recursive formula in order to get there. So if we look at our now next, we're doing our starting point is 1, and then we're going to do now times 5 to get to the next number. Now if we wanted to skip some numbers, what we're going to do now is make this equation. So I got my y equals, I know that my first initial term is a sub 1, so that's my start, these are the same, and then I've got times 5 each time, so I know that my common ratio is going to be 5, so I sub it into my formula, and then I raise it to the x power. And then this is going to help us shortcut and get to maybe the 10th term or the 20th term, so we don't have to do all of that math and multiply by 5 a whole bunch of different times. So here's our example. We've got bacteria growth. We don't really know anything about it other than as hour 0, we have 1 bacteria. After 1 hour, I've got 4 bacteria. After 2 hours, I got 16. So what I want to do is what we did before, figure out my common ratio, figure out if it's geometric. So I do my 4 minus 1, that's 3. If I add 3 each time, if I add 3, that's 4, that's 7, that's not 16. So now I do 4 divided by 1. 4 divided by 1 is 4. Multiply by 4, multiply by 4. So that looks like that's what's going to happen. So if I keep multiplying by 4, I get 64. And then I get 64 times 4. Gives me 256. And then 256 times 4 gives me 1024. So I know that my growth factor is, or my common ratio is 4. That's what I'm multiplying by each time. So then I'm going to now plot this point. I went ahead and just went up by 50s each time. It's kind of up to you as how you grow it. Just remember you have to add the same amount each time. So I'm going to go and plot these points at 0. I've got 1, so that's pretty low down there. At 1, I got 4, still pretty low. 2, I got 16. It's kind of getting a little bit taller. 3 is at 64. So we're starting to get up there. 4 is at 256, which looks like it's up there. And 5 is not even going to be on my graph, which is okay. And you should see we get that J curve that looks like an exponential function. So now knowing this, we know that our pattern is 4, so now we can answer this question of whether it's linear or exponential. We know that it's exponential. My start is always when my hour is 0 or my x is 0, so my start is going to be 1, and we said that we're multiplying by 4 to get that pattern. So now I want to write this y equals. So in order to do that, I need my r. I know that my r is 4. I know that my starting point is 1, so I got 1 times 4 raised to the x power. So now, knowing that, I want to figure out after how many hours, or after 7 hours, how many am I going to have? Now, what I could do before was I could just keep on multiplying by 4. But now, having this equation, I can then use my calculator, do 1 times 4 raised to the 7th. So I got 1 times 4 raised to the 7th. Remember, your raising button is right here, this little caret. That's going to make it an exponent. Hit enter. And you see that we get 16,384. So this is 16,384 bacteria. Now the other part is this. How long until you reach 1,000,000 bacteria? Now, in order to solve this algebraically, you would need logarithms. But we haven't learned logarithms yet, and you won't learn that until Math 2. So what we're going to have to do is kind of this strategy of we multiply by 4 each time and just kind of keeping track. So I'm going to start with my 1. Remember, you hit 1. I'm going to clear everything. So you're going to press 1, hit enter, and then you're going to do, remember this is a recursive formula, so we multiply by 4, and then I hit enter, so I get my next term, so that's 1. Then all I have to do now is just keep hitting enter. So I've got to my 3rd term, 4th term, 5th term, 6th term, 7th term, and I'm looking for when my growth is bigger than 1,000,000. So that's at 7, that's 8, 9, getting close, and then at 10, I get over 1,000,000. So my answer is going to be at 10 hours, we're going over 1,000,000 bacteria. So that would be how we would get this equation. This equation is going to help us get this one, where we get to jump. We're still just doing the recursive formula for how long it takes to get over 1,000,000 though. So now we're going to work backwards on this one. So now we've been given the equation. And what we want to do is kind of work backwards and get kind of our initial stuff. So remember, our formula is y equals a sub 1 times r raised to the x. A sub 1 is my initial value. R is my common ratio. So I notice this is my initial term. So it says, what is the area of the mold at the start? So at the start, I've got 50 square millimeters taking up. And then it says, what is the growth factor? The growth factor is the same as the common ratio. That's my R. Looks like my R is going to be 3. So 3 in there. So now, I can answer these two questions based on this. So I know after 5 days, I plug in 5 into my calculator. So I got 50 times 3 raised to the 5th. So 50 times 3 raised to the 5th. I get 12,150. Yeah, and that would be in millimeters squared. Now remember this one, it says how long until the area reaches 6,400 millimeters squared. So I start at 50. So I go 50, hit enter. Then I'm going to do times. I'm doing times 3 each time. So I'm doing my answer times 3. So that's after 1 day, 2 days, 3 days, 4 days, and then 5 days. After 5 days, it makes it over 6,400. So 5 days is how long it takes in order to reach 6,400. It is a little bit less, so it's a little bit less than 5 days, technically, but you get the idea. So that is using the formula y equals a sub 1 times r raised to the x power.